Okay, so we're looking at loan problems today. Our first one is a fairly straightforward problem. Anton borrows 100,000 Swedish crowns for a car. He pays the bank at the end of every year at a rate of 7% interest. He pays the loan in 4 years. How much should he pay each year? And how much does the loan cost him? So first up, we want to figure out how much is his loan repayments going to be. We'll pull up our calculator. We want the finance solver. So, how many payments is he making? Four. So we're going to have 4 payments. What is the interest rate? 7%. The present value?
100,000.
Positive or negative?
Positive, because you're borrowing it, so it goes into your bank.
Positive, because it goes into his pocket. Payment?
Payment?
Empty.
That's what we're going to find, isn't it?
Future value stays
Zero.
at 0.
Why?
Because he needs to pay the bank back, which means he needs to get it back.
He needs to pay the bank back, and it needs to be 0. So how many payments per year?
1, because it has
How many compounding periods per year?
1.
Beginning or end of the year? End. So that should be enough. Press enter here on that, and we get our value. So let's write down our method. We've got n is equal to 4. Interest rate is equal to 7. The present value is 100,000. The future value is going to be 0. Payments per year, 1. Compounding periods per year is 1. This gives us a payment monthly of minus 29, 522.81. So he pays, we give a conclusion in words with a positive value, 52281 crowns each year. Use the words in the question back to them. How much does he pay each year? He pays this much each year. So look to use the words in the question back. Next up, we need to look at is how much does the loan cost him? How do we calculate this? What do we times by 4? The payment. So if you have the payment here in your finance solver, press Control C, and then Escape to exit, and then Control V. We get the value here. We times it by 12. This is how much. No, why am I times it by 12?
I did something drastically wrong.
Let's times by 4, but I'll times by minus 4 because I'm sick of it being negative. I don't want it to be positive, and this looks better. So we need 4 times 29,000. 52281 is equal to 118,091.25. What is this number?
That's the total. That's the total amount of money he has to pay back.
That's the total amount of money he gives the bank.
Yeah.
Is this the cost of the loan?
No.
How do we find the cost of the loan?
Subtract 100,000.
So the cost of the loan is 18,091.25 crowns. Okay, let's have a look at the next question. All right, I'll just give you a second. All right. Okay, Tejas takes out a loan for 35,000 for a car. The loan is 10 years at 1% interest per month. How much does he have? How much? Find out. Find how much he has to repay each month.
3,000
So because the interest rate is in months,
Yeah.
think in months on everything. So the compounding period per year is compounding period per month, payments per month, end of months. Think of everything in months and it'll be easy. I'll give you a minute or two to solve this one.
Yeah, when I first read that question, I didn't read the last bit, so I did it in years and not in months. And then I read the question again, I was like, oh, yeah, I should have read it more thoroughly.
So do we put it for beginning or end of the year if it's each month?
Always go for end of the year
Okay.
or end of the month.
Unless stated otherwise, right?
Yeah, I've not seen them do it. They all
Why?
pretty much it's going to be end of the year always. End of the
Oh,
month.
why is it 7? You need to know. No, why is it
The
7?
payment.
You're wrong, not me.
That makes sense.
It looks like
Yeah,
a 1.
because
Maybe no, it's
payments
a
always
8%
end,
with
you're
a
never going to get the payment at the beginning or something, right?
There, okay. So what we have for the compounding period? Why? What are you doing about?
1.
1, right? Yeah.
Yeah, because everything's a month now.
Okay,
Yeah,
so
right.
compounded and,
How are we getting on?
I like math when it has to do with so good. $6. So would you ever change this costume? No, right? It's a pretty good costume.
I like it.
Yeah, it's a good.
I will. I foresee the thing if we play forced upon me, especially when that gets finished.
That's a good.
If I have the choice, I like to say. View, like the light, like the proximity of the photography, like
So
size of
create
it.
100
I would do badly in an odd-shaped room.
Like one of the curved ones.
Yeah,
like that.
106.
Yeah, it's really odd. You can't open the window either.
Well, it would bother me. You know, a little bit of a secret.
Sir, is it 306?
Let's find out. Let's find out.
You're right, right.
Okay, let's see how Tejas is getting on. So Tejas takes out a loan for 35,000. Let's pull up the finance solver. So 10 years every month. How many payments will he make?
120.
He'll make 120 payments. What is the interest rate? 1%. What is the present value?
Positive 35,000.
I put negative like up.
It will work positive and negative, but we try and keep it in one direction always, just to be consistent. So 35,000 is what he is given by the bank. So it goes into his pocket. Payment, we're going to calculate that. That's going to come out of his pocket.
Future value is 0.
Future value is 0. So we're going to, because the interest rate is in months, we are thinking in months. So this is payments per month now. 1. Compounding periods per month. 1. So don't try and mess around and change the interest rate into an annual one and the compounding periods into months and all that type of stuff. It will work and you get the same answer.
Oh, that's because that's what I did.
Yeah, it will work. You make this into 12, you make those into 12, you're going to get the same answer as well. In the same way that if you go positive or negative, you get the same answers. But I try and be very consistent on this. And we are going to get this value.
Oh, I did not.
Yeah.
I think anybody got that there.
Yeah.
No, have I gone wrong
Sir,
somewhere?
because PPY is payments per year, so you can't convert it to months.
Yeah, but
Per month.
the calculator is thinking that it's going to be for 120 years and one payment per
Year. But wait, I still don't
So we know what
I
to
don't
do.
want- I don't negative, or sorry, 200 is just quite sad.
I think it's
Because I don't know. I want to know.
Let me check it through. Let me think it through. Yeah, okay.
I'm getting a different answer than what I got the first time. The exact same amount.
Oh, you're right. You did not put on. She's here.
No, this is correct. No, this is correct. $502. Okay, let me just pause the video and I'll come around and see what you did and how you got it wrong. Okay. So let's have a look at our answer. I would recommend that we think in months. I'll show you how we can do it, how you guys can fix yours. So we've got 120 here. Our interest rate is 1%. Our present value, we're getting 35,000. Our future value is going to be 0. Payments per year and compounding periods per year. Think in months. So this is payments per month, compounding periods per month. We've got 120 months. We're paying once a month. We're compounding once a month. All of this is caused by the fact that the question has given us a monthly interest rate here. All of these issues are caused by this. So we have to do the slight shift in our problem solving. This is going to give us a payment of minus 502.15. Answer in words. He pays each month. He pays, answer with a positive value. We've got euros, 502.15 euros each month. Now, you can use the finance solver in many different ways. For this question, if you wish to think in terms of years, you're still going to have 120 payments, but your interest rate would be 12% because you have to times it by 12. Your payments per year would be 12. If you're thinking in terms of year, and your compounding periods per year would be 12.
Wait, so you can do it.
So it's just unnecessary extra step.
Yeah.
But can you do it like that?
Yeah. If you do it like that and make these alterations, it would fix.
But then the value.
So your N here is related to the payment, how many payments you're making. Your interest rate here is related to your compounding periods per year, like this one. So these two are linked in your file.
And then the answer you get based on that, would you have to divide it by 12 to get it per month, or not? Or you can...
No, it would still give you the monthly payment.
Oh, okay.
It would give you the monthly payment. All right. So moving on. Let's have a go at this one. This is a past paper question this time. Take a few minutes to go have a go at this one. I'll pause the video for this. All right then. Let's have a look. So Daisy invests 37,000 Australian dollars in a fixed deposit account with an annual interest rate of 6.4%, compounded quarterly. Calculate the value of Daisy's investment after 2 years. So how many payments? What's the payment? The monthly payment? What?
0.
There is no payment. So when there's no payment, if you're not making regular payments, your N is years. When you're not making regular payments, N is your years. So how many years is this?
2.
This is 2 years. Interest rate,
6.4.
6.4. Present value,
37,000.
so minus 37,000. Payment, 0. Future value is what we wish to calculate. Payments per year, we leave at 1. But because the payment is 0, we make one payment of 0 per year. It's not going to change anything. Compounding periods per year, 4. So we go back up to future value, delete that, press enter, and we should get this. So putting down our method, we've got n is 2, I 6.4, present value minus 37,000, payment 0, compounding periods per year is going to be 4.
Sir, I have a question. I had it accidentally on 4 payments per year, but the payment and it made it wrong, but the payment is 0. So how does that change anything?
I'm not quite sure on that one, so that's why I always said to 0, 1. So we are going to get 42,000.
42,009.87.
0.87 AUD. So the value of the investment is this. Yeah, I'm not going to mess things around. There are other ways to enter the interest rate and the compounding period, but I won't do that. I'll stick to a consistent approach. After n months, the amount of money in the fixed deposit account has appreciated to more than 50,000 dirhams, Australian dollars. What's the minimum value of n? So we wish to have a future value of how much?
50,000.
50, 1, 2, 3. Nothing else changes apart from now we don't know how many months it's going to be.
We just delete n
4.5.
and oh, sorry, I did. Yeah, I got 4 points.
Okay, so we need to have this one.
And then you times that by 12 because we need to find the number of months, and that's the number of years, right?
Before timesing by 12.
Not by
Before timesing by 12.
No, by 12. Yeah.
Before timesing by 12, I would recommend rounding up to the nearest quarter. So this is in years, 4.74 years. When do the quarters occur?
Every 3 months.
Every 3 months, but in terms of years?
0.3. Or no, that's
0.75.
0.4.
It would be 0.75.
The next one will be 4.75. It will occur every 0.25. So 0, 0.25, 0.5, 0.75, 0, and so on. So round up to the nearest quarter, because this one's compounded quarterly. And this is, you're not going to get it wrong, whichever, if you just times by 12 and round up to the nearest month. But you could, if this came at a number like 4.51, you would get the wrong month. So it has to be one of the quarter months. So what we want this time then is everything else is the same. N is what we're calculating. I is 6.4%. Present value minus 37,000. Future value is 50,000. Compounding periods per year is 4. And this gives us n is equal to 4.74. So round to the nearest quarter. Which is 4.75. And and then 4.75 times 12. So we need 4.75 times 12. Oh, 4.75 times 12. 57 months. So after M months, the amount of money in the deposit has appreciated to more. What is the minimum value of M? So this is 57. So M equals 57 months. That can't be right.
It's just sad.
That can't be right. That's not a quarter month. So 56 months would be a quarter month.
So we have
It has to be divisible by 4. Is it the first? Is it so 0,
it would have to be the 59. No?
0, end of January, 1, end of February, end of March, 3. No, it's not quite divisible by 3, is it?
What if we just
Okay, I get it. So for it to be a quarter month, it has to be divisible by 3. That's not by 4. That's why it's like that. So yeah, 57 months. Okay, let's go to the next question.
I'm hoping I did this next question right.
Okay. Another past paper question. Paul and Rosie want to buy a house, take out a loan. Have a go at this question. I'll pause the video, give you a few minutes. All right. So the first question isn't so challenging. Raoul and Rosie want to buy a house. They need 170,000 Australian dollars. They are taking a loan for 30 years, annual interest rate of 3.8%, compounded monthly. They'll pay the loan in fixed monthly installments at the end of every month. So because we have a monthly payment, N is going to be the number of payments. If we don't have a regular payment, N is the number of years. Always. Always think this way. So if we are going to have 30 years and 12 payments a year, so we need 30 years and 12 payments per year. Gives us 360. Our interest rate is 3.8%. What about the present value? Positive or negative?
Positive.
Why is it positive?
Because they're taking it from the bank, they're not giving it.
They're taking it from the bank. What about the payment?
Blank.
Blank. That's what we're calculating. Future value?
Zero.
0. Payments per year?
12.
Compounding periods per year?
12.
12. So let's circle back around to the payment, press enter.
Yeah.
So for A, we are going to need N is 360, I is 3.8%, present value, 170,000, future value 0, payments per year 12, compounding periods per year 12, gives us a payment of minus 792.13. They pay the bank. They pay bank 792. Always answer with a positive 13. Australian dollars. B. Find the amount Raoul and Rosie will still owe the bank at the end of 10 years. So how many payments have happened after 10 years?
10 times 120.
So 120. Nothing else changes. The payment is still going to be the same payment. What we want now is the future value. So we've calculated the payment. We're going to keep making those payments that we calculated correctly, but only for 120 years, and then see what the future value of the loan is. Okay, so we want N is 120. I is still 3.8. Present value is still 170. This time we're making the payments of minus 792.13. Payments per year are still 12. Compounding periods per year also 12. This gives us a future value of minus 133.020. Decimal point 0.30. So use the words in the question. They owe the bank 133.020. Answer with a positive 0.30. Okay, the last one is tricky on this one.
I think I did the last one.
Okay. So, what we want to find out is two things. We want to find out how much money they've given to the bank and how much of the debt they've repaid. So let's start off by calculating how much of the debt they've repaid. We're going to have to do this on the calculator screen. But with this information, how would we calculate how much of the loan has been repaid?
How much?
Subtract.
Sorry, let me take some big.
Subtract your initial by the amount we just found after something.
Use the letters.
So it would be 170,000 minus
The present value
the value minus the future value.
minus the future value. That will show you how much of the loan has been repaid. So let's start off with that. I think we can remember what that one is, but for the future value, I'm going to do Control C, and then I'm going to press Escape. So future value, I'm going to call F. Can I get them here? Or... Oh, I can get them here. Oh, I can get them here. Future value.
That's awesome. Oh my god, that makes it so much easier than copy and paste and
So,
going back.
Yeah, present value, variables, and then future value. So because the present value is positive and the future value is negative, if I add these two together, it should give me this. What is that number?
That
No,
They paid.
the amount of,
They owe.
it's not the amount they've paid more than that.
The amount they do.
They still need
So,
interest.
no, it's the
Don't guess, think. So the present value is what?
present value is what they've the loan.
Is what they've loaned. Future value
The future value
at 10 years.
is the value that they still owe.
Yeah.
Future value is the value at the steel owe. Let me just do 8-1 so we can see these. Present value is what they borrowed.
Yes.
Future value is what they still owe. Difference between these two?
How much they paid to the bank.
No.
The difference between them is
It's not how much they've paid. They've paid more than that.
yeah, they pay more than them. It's
So the present value, this 170, that's the principal. 36,000 that we've calculated it between these two is how much of the principal has been repaid.
Okay.
It's not how much they've paid the bank, they've paid the bank more because of interest.
Yes.
This value that we're calculating is how much of the principal they have repaid.
So how much of exclusively the loan they've repaid?
Okay, so they have repaid, and I'll just do this in three significant figures. 170,000 minus 133,000. So I'm writing in three significant figures, but I'm calculating exact, as we always do. So they have repaid, what is this in three significant figures? It's 37,000, isn't it? I'm just going to round up and round up again. So if I round here, rounds twice. It's equal to 37,000. This is how much they've repaid.
On the calculator, you add
Because, watch the values. The future value, negative.
Yeah.
Present value, positive.
like.
So I thought that, yeah. It's a bit tricky. You could, if it's easier for you, get the values out like this, look at them, and then go and check, or even go up and change them. So if you want, times it by -1, make this one positive. So now you do this number minus this number. So if you're seeing them, it helps you.
Yeah.
So that is how much of the principal has been repaid. We want to calculate how much did they give their bank. They gave the bank how much? How much do they give the bank each month? Which one of those is it?
It is.
PMT.
This is how much they give the bank every month.
Yes.
How much have they given the bank in total at this point?
792
Times
120.
This is how much they've given the bank.
Yeah.
Why 120?
Because that's what
That was the first
10 years of monthly payments.
That was the first.
They gave the bank, so I'll do it in three significant figures. 792 times 120. So they gave the bank, and then in three significant figures, that's 95,000. 95,000. So, how much, what's reading the question, using your answers, how much interest have they paid in the first 10 years?
Subtract
Oh.
37,000 and 95,000.
So, how much interest paid? So use their words back. Interest paid. How do we calculate this one?
Subtract 37,000.
From 9,000.
Yeah, so 95,000 minus 37,000. So I'll do it in three significant figures again. 95,000 minus 37,000. And I'll answer in exact, in two decimal places now. So I'm using the exact values over here. Where's my 95,000? That's this one. Let me make that positive. Stop! Damn you, calculator. Okay. So I want this value, I want to make it positive, I'll times it by -1. So I want this value. What do I want to do? I want to take away the 37,000. So that's this value up here.
Yeah.
So I subtract this exact value up here. That one. Is that the 37,000?
Yes.
Okay. I subtract that one. So this is now the exact calculation, not the three significant figure one. And
The interest, sir.
so this is the interest that they've paid. So they've paid more interest than they've repaid of the actual loan at this point.
That's
That's good.
This is how an annuity loan works. If we have more time, I can show you in more detail the different ways different types of loans work. Not today. We can go into a bit more detail towards the end of the course if you want. But an annuity loan, you're only paying interest in the first 15 years or so. It's only in the last part of the loan you really start to repay the principal. There is another type of loan system called a straight line amortization loan. And with a straight line amortization loan, you pay the same part of the principal off every month, and you pay whatever interest that month. And in this type of loan, your payments are really large at the beginning of your loan period, but quite small at the end of the loan period. You repay the same amount of principal every month, and this type of loan is cheaper. But what's better about an annuity loan is the monthly payment is fixed. So you can do your budget and you can plan your life easier. Whereas with a straight line amortization loan, which is cheaper, you have to pay massive amounts at the beginning. And usually at the beginning of a 30-year period for this couple, that's when you're broke. People are richer at the end of your parents are coming into the point now where they're rich. But when they started out and they were newlyweds, usually they're a lot poorer, they've got young kids, it's a lot harder, this is normal life. So you're usually poorest around about the time when you're 30, when you've got a couple of kids and you're just starting out with a house and everything. That's not the time for a straight line amortization.
Thank you for the advice. And thanks for not charging anything.
Okay, that's how we go. This 1,
3 minutes.
All right, I'll do it. We've got 3 minutes. I'll go straight into it.
okay.
Remember the last time that you called for an hour and 20 minutes straight?
Okay, Jen invests 2,400 in a savings account that pays 4% interest compounded annually. She leaves money in the account for 10 years and does not withdraw. So this is a fairly easy one. I won't write up the methods as well, just to save time. But what we need to do on this one is we are going for, she just puts money in and leaves it there. There's no payment. So how many years is it?
It's 10 years.
10 years. What's the interest rate?
4%.
4%. What's the present value?
2,400.
Positive or negative?
Negative.
Why is it negative?
She's putting the money.
She puts the money in. What's the payment?
The payment is 0.
0. Future value is what we want to calculate, but let's. What's the compounding period? Annually. So we want one payment and one compounding period, and then we want to calculate we wish to calculate the future value. So this is the future value. So for A, the future value is 3552.59. So the rate of inflation during this 10-year period is 1.5%. Calculate the real value of her savings. So the real value is going to be given by the interest rate minus inflation.
Yeah.
So we end up with an actual real interest rate of 2.5%. Because although the money increases, so does inflation. So in this particular case, we need to change the interest rate to 2.5%, and our future value is only going to be 3,072. All right, we're finished there for today.
Thank you so much, sir.
We finished completely.
Yeah,
What?
that is the end of the course. You need to work with.
so much. 10 out of 10.
You need to work with exercise 10G on page 481 for homework, and then that is it.
Thank you so much. 10 out of 10.
Thank you so
Great
much.
lesson, 5 stars.